Hello everyone, I am Anupam Indradeep Singh, a first year BTech student of BIT Mesra of the branch EC section B. And today we are going to have a quick glance on the topic half-wave rectifier. A rectifier is a device that transforms the AC voltage to a DC voltage. On the similarity, we have a half-wave rectifier. A half-wave rectifier transforms only the positive half cycle, that is the first half cycle of the AC voltage into the DC voltage, and the negative half cycle, that is the second half cycle, we get the output voltage as 0. We could analyze the situation from the given circuit as shown below. In the circuit, Vi is the input voltage. The given diode is a non-ideal diode where Vb is the barrier potential of the diode and Rd is the resistance of the diode. R is the load resistance, I is the current through the circuit, and Vo is the output voltage. For the first positive half cycle, the diode is forward biased. So by applying the KVL in the given circuit, we get the equation as Vi minus Vb minus IR into Rd minus I into R is equal to 0. From this equation, we get the current in the circuit as Vi minus Vb upon Rd plus R. Now, in order to get the output voltage, we write the equation as Vo is equal to I into R. And by putting the value of I from the above equation, we get the value of output voltage as R, capital R upon small rd plus R into Vi. And in most of the general cases, the diode is an ideal diode, and the value of the diode resistance is very small as compared to the load resistance. So we get the output voltage as Vi minus Vb for the positive half cycle. For the negative half cycle, we could analyze the situation from the given circuit below. Now in this case, as the circuit diode is reverse bias, so the diode acts as an open circuit, because of which by applying KVL we get the output voltage as 0. So from this both the circuits, we could say that in a half-wave rectifier, only the first half cycle of the input waveform gets rectified, and the second half, that is the negative half cycle, we get the output voltage as 0. Now we will analyze the waveforms of the half-wave rectifier. The first diagram represents the input voltage, where Vm is the peak voltage, x-axis represents the time, and y-axis represents the input voltage. The graph below the input voltage is the graph of the rectified graph of a half-wave rectifier, in where we have used a non-ideal diode. In this case, the peak voltage is Vi minus Vb. Because the diode is non-ideal, so we should have considered the barrier potential of the diode. Now Vb is equal to 0.7 volt for your silicon diode and 0.3 volt for the germanium diode. And just in the case of an ideal diode, as the Vb is approximately equal to 0, so we get the output voltage as Vm, that is equal to the peak voltage. Now, in order to get the average output voltage, we have the equation as V output is equal to Vm sin omega t, where omega t, this equation is for omega t from the time period 0 to pi, and for the time period pi to 2 pi, the V output is 0. Now, V average can be written as integration 0 to 2 pi Vo d omega t by 2 pi minus 0. Now, we could break the integral from 0 to pi plus 0 to 2 pi. On solving this integration, we get the value of V average as Vm by pi. And by using this value, we could also get or obtain the average current value. So average load current can be represented or given by the equation I average is equal to V average by R, where V average is equal to Vm by pi and R upon R. So from this above equation, we could get the I average as Im by pi. Thank you.